Lazy Perfectionist 1. You're going to get tired of me by the time I'm done. But this is a response to your question for science details of an atom. All of your premises are correct to the best of our knowledge. Now, your question, is it possible for atoms to lose more than one electron or gain more than one electron? The answer to that is yes. Go to www.webelements.com. It's just the standard periodic table of elements. I'm sure you've seen thousands of them. Okay? The way they are arranged helps to give you an idea of, first of all, will an atom gain or will it lose electrons, and how many is it anticipated to gain or lose? The first line is hydrogen and helium. Hydrogen has 1 electron. Helium has 2. Now, these electrons are floating around the nucleus, and they're floating in energy levels. Think of them as racetracks. Okay? These energy levels like to have as many cars on their racetrack as they can handle. Well, the reason those are the only two on that line is because that specific racetrack can only hold 2 cars. Now, the objective that atoms want to do, atoms want to be happy. They want to have as many full racetracks as they can easily do. Okay? So, hydrogen would gain an electron to have 1 full racetrack or energy level. While there's nothing to my knowledge that specifically states no, a hydrogen cannot lose an electron, the argument then becomes, is it a positive is it a positive hydrogen atom, or is it just a proton? So, if you look at the second line, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon, well, this is the second energy level. Neon has 2 full energy levels. You have to fill up the first racetrack before you can move on to the second one. Okay? Lithium has 3 electrons, which is 2 on the first racetrack and then 1 on the second. It really doesn't care about that one, so it's going to give it over to some fluorine or something. Maybe some, as a matter of fact, some chlorine. Okay? So then you'd have lithium chloride. You've just created an ionic bond. Beryllium has 2 on the inner, 2 on the outer. It really doesn't care about those 2. So beryllium could either give it to an oxygen to make beryllium oxide, or it could give it to 2 fluorines to make beryllium difluoride. Please note that I'm just making this stuff up. I'm using logical possibilities. Feel free to correct me if you know that these combinations don't exist. Now, beryllium, it has 3. Oh, I'm sorry, boron has 3. 2 on the first, 3 on the outer. It really likes its electrons. So instead of giving them away to have one full, it's going to try to hoard them. It's going to try to get up to it wants to hang with Neon. Neon doesn't want to hang with anyone who doesn't have 2 full energy levels. So beryllium hoards as many electrons as it can to go and play with Neon. Now, oxygen combines with 2 elements of hydrogen. We all know this, H2O. But it's a covalent bond. See, boron is greedy. It wants to hoard electrons. Oxygen likes to share. So, it needs 2 more electrons before it gets 2 full energy levels or racetracks. So, goes over, finds 2 friends of hydrogen, and says, hey, you've got one, I need 2. Instead of me just taking them from you, let's share our electrons. Then, both hydrogens share one of oxygen's electrons to pretend like they've got a full energy level 1. Then, in turn, the 2 hydrogens share their 1 electron with oxygen, allowing it to pretend that it has 2 full energy levels. This is a covalent bond. This is the nature of atoms. So, I hope this has cleared things up for you.